In this question, we have the population of elephants in Botswana is 214,000. And for those interested, here is Botswana down above South Africa. And the population of elephants is 214,000. So this P0 is 214,000. So the population the next year, P1, will be 214 multiplied by the growth rate of 2% plus 1 by 1.02. And then only 800 die because of enlightened policies by this government. So we'll have to take away 800 to get what will be in year 1. So if we convert this in terms of P0, we're told P0 is this 214. So in terms of N, this will be the population in year 0, 214. Being P0 by 1.02, then this will become the population in N minus 1 by 1.02 minus 800 to get our Pn. So let's just fill them in. When N is 1, we'll get P1. When N is 1, we get P1 to be P0 by 1.02 minus 800. Building it up, when N is equal to 2, we'll get P2 to be the population in year 1 by 1.02 minus 800. And to get it all in terms of P0, let's substitute P0 in for P1. This is what P1 is underlined, so P2 becomes the population in year 1, which is P0 by 1.02 minus 800. That will all be multiplied by 1.02. We still have to take away the 800 at the end. So we're going to get P0 by 1.02 to be squared minus 800 by 1.02 minus the other 800 for P2, and we sub N is equal to 3 in to just expand it out a bit. When N is equal to 3, we get P3 to be equal to, just putting 3 in here, P2 by 1.02 minus 800, and subbing in all of P2, we're going to multiply all of these by 1.02, so we're going to get P3 to be P0 by 1.02 squared by this 1.02, so we're going to get P0 by 1.02 to be cubed minus 800 by this 1.02 and then by this one, so that will be squared. And then we're going to get minus this 800 by the 1.02, and then we're going to take away the 800 at the end, and this will create a pattern for us. So we have P2 on its own by 1.02 cubed. If we reverse this pattern around, we have plus 800 or minus 800 in fact. Factored out, we'll have this times 1 minus the 1.02 that's beside it, and then the last term of this sequence will be minus 1.02 to be squared. So in terms of N, we're going to get Pn by 1.02 to be cubed minus 800 times this geometric sequence where A is equal to 1 and R is equal to 1.02. So we just do that one on its own. Sn is equal to A times 1 minus R to the power of N divided by 1 minus R. So this is going to give on the bottom minus 0.02, and on top 1 times 1 minus 1.02 to the power of N, and 1 divided by, it's like multiplying it by 50, so that's going to give minus 50 times 1 minus 1.02 to the power of N. And we're also going to have the minus 800 in front, so that's going to give minus 800 by minus 50 is 40,000. It's going to be a plus with the two zeros, and that will be in front of this bracket, so times 1, and then times minus 40,000 times 1.02 to the power of n, minus 40,000 by 1.02 to the power of n. Now we also have Pn by 1.02 to the power of n here. Bring the 3, power 3 becomes n, so we're going to get Pn by 1.02, sorry, to the power of n, P0 in fact, P0. So we're going to get the original P0 of 214 by 1.02 to the power of n. We also have minus 40,000 of them. And we have the plus 40,000 in the middle. Maybe a bit messy. So we're going to get, looks like 174 of these, 174,000 by 1.02 to the power of n plus 40,000 is going to be the population of this elephant herd in Botswana. This is going to get larger and larger. What can you predict? Well, it's going to keep growing, isn't it? Let's have a look when n is equal to 10 and when n is equal to 50. Let's have a look at this elephant population. I'm getting 252. I'm getting 212 plus 40, 252, 105 elephants in 10 years, and in 50 I'm getting 508, 33. 6.3 or 336, so it's growing. There's going to have to be some culling going on at some point, or there'll be elephants roaming the world and no humans.